Hello and welcome, dear listeners. I invite you to join me on a journey through the cosmos, a journey that begins not in the vast emptiness of space, but right here in the quiet comfort of your own mind. Before we look up, let us first settle in. Find a comfortable position. Whether you are sitting in your favourite chair or lying down to rest, let your body sink into the surface beneath you. Take a deep breath in, filling your lungs with the cool, steady air of the present moment. Hold it for just a second and then exhale slowly, letting go of the tension of the day, letting go of the noise of the world. Close your eyes and let your imagination become your eyes. I want you to transport yourself forward in time. Visualize that it is early morning. The date is November 11th, 2025. It is that very specific time of day just before dawn when the world holds its breath. The sky is not quite black anymore, but it is not yet blue. It is a deep, rich indigo, a velvet curtain that hangs over the horizon. The air is crisp and cold, typical of late autumn, and there is a profound silence that only exists at this hour. In this imaginary moment, you are standing at a window looking out toward the east. The stars are beginning to fade one by one, surrendering to the approaching light of the sun. But there is something else out there, something that has been waiting for this exact moment to reveal itself to you. For the past few weeks, the astronomical community and skywatchers around the globe have been holding their breath. The object known as 3YE/Atlas had disappeared. It had travelled behind the glare of our sun, hidden from our view, masked by the brilliant light of our own star. For a while we did not know if it would survive that fiery encounter. Many comets do not. They break apart, crumbling into dust under the intense heat and gravitational pull, but this one is different. On this morning, November 11th, the wait is over. As you look toward the eastern horizon just before the sun breaks the line of the Earth, you see it. It has survived. It has re-emerged from the solar glare, waking up the night sky with a presence that feels both ancient and brand new. This is the awakening we have been waiting for. It is important to understand the rarity of what you are seeing in your mind's eye. This is not a nightly occurrence like the moon rising, nor is it a predictable yearly event like a meteor shower. This is a feeling of absolute uniqueness. The path this object is taking through our solar system is not a simple loop that brings it back every few decades or even every few centuries. This specific moment, this specific angle of light and this specific position in the sky will never happen again in the history of humanity. The photons of light that are travelling from that object to your retina are carrying a message that is exclusively for this generation, for this year, and for this very morning. It is a singular event in the timeline of the universe. If you were to miss it, you would miss it forever. There is a haunting beauty in that thought that the universe has arranged this display just for now. As you watch this point of light in your imagination, it might seem still. It hangs there in the twilight, serene and calm. But this stillness is an illusion caused by the vast distances of space. In reality, the object is moving with a violence and speed that is difficult for the human mind to comprehend. Let us try to wrap our minds around the numbers written out in plain language. Right now, as it pierces through the darkness of the solar system, 3I/Atlas is travelling at a speed of roughly 152,000 miles per hour. Think about that speed for a moment, 152,000 miles per hour. To put that into perspective, a commercial jet flies at about 500 or 600 miles per hour. A speeding bullet travels at roughly 1,700 miles per hour. This visitor from the deep cosmos is moving at a velocity that renders our fastest machines motionless by comparison. It is tearing through the fabric of our solar system, covering vast stretches of the void every single second. It is rushing toward us, and yet it is also rushing away. It is a traveller on a hyperbolic trajectory, meaning it is just passing through. It is not here to stay. It does not orbit our sun in a comfortable circle. It is falling toward us from the dark, cold outer reaches, swinging round, and then it will be flung back out into the unknown, never to return. This creates a sense of urgent beauty. We are currently in a race against time. As we stand here in our imagined morning of November 11th, we are entering the final act of this cosmic play. The window of opportunity is closing. The month of December will be our last true chance to witness this spectacle in all its glory before it fades back into the eternal blackness. There is a profound emotional contrast here that I want you to feel. Think about where you are right now. You are likely in a warm room. You might be under a blanket. Your breathing is slow, your heart rate is calm. Everything around you is stationary and safe. Now contrast that with the reality of 3I/Atlas. Out there in the vacuum, there is no air, there is no sound. There is only the silent scream of rock and ice flying at 152,000 miles per hour. It is a chaotic, freezing, lonely environment. And yet these two worlds, your quiet safe room and that violent rushing comet, are connected by a single line of sight. For this brief period in history, you and that object are dancing together. You are the observer, the witness to its lonely journey. It is almost as if the sky has woken up specifically to show you this. The awakening of the night sky is not just about the object becoming visible. It is about us down here on Earth waking up to the grandeur of what is happening above our heads. As the sun begins to creep higher in your visualization, washing out the stars, the comet fades from view for the day. But you know it is still there. You know that while you go about your daily routine, eating breakfast, going to work, talking to friends, that massive traveller is still out there racing at 152,000 miles per hour, preparing for the next night, preparing to show itself to you one more time before it leaves forever. This is the context of our journey. We stand on the precipice of a final goodbye, witnessing a dawn that heralds both the arrival of a new day and the departure of an ancient guest. The sky is awake, and it is calling for us to look up. The story of the Great Comet of October 2025 is not just a story about a bright light in the sky. It is a story about geometry, it is a story about perspective, and most importantly, it is a story about the things we cannot see even when they are right in front of us. As we moved through the early days of the comet's approach, the world was looking up. Telescopes were pointed, cameras were ready, but the universe has a way of keeping its secrets. Just as the object was about to reach its most critical moment, just as it was preparing to dance with the fire of the sun, it vanished. This was not magic, it was not a sudden disappearance of matter. It was a phenomenon known to astronomers as solar conjunction. To understand why the most watched object in the solar system suddenly became invisible to the naked eye, we have to talk about the simple, elegant, and sometimes frustrating geometry of space, the dance of angles. Imagine you are standing in a dark field at night. Far away there is a lighthouse. The beam of the lighthouse is incredibly powerful, cutting through the darkness. Now imagine a small moth flying toward that lighthouse. When the moth is far away from the light, you can see it clearly if you shine a flashlight on it. But as the moth flies closer and closer to the lighthouse lens, it disappears. It is not gone, it is simply lost in the glare. The light from the source is millions of times brighter than the tiny reflection coming off the moth. This is exactly what happens during a solar conjunction. In the vast three-dimensional theatre of our solar system, the Earth, the Sun, and the comet are all moving actors. Conjunction is simply a fancy word for alignment. It means that from our point of view on Earth, the comet and the Sun have moved into the same part of the sky. Usually we love alignments. Eclipses are beautiful alignments. But when you're trying to track a ball of ice and dust, an alignment with the Sun is the worst possible scenario. As the comet speeds up, rushing toward its closest encounter with our star, the angle between the Sun and the comet shrinks. In the language of astronomers, we say the elongation decreases. When this separation angle becomes too small, the comet enters the daylight sky. It rises when the Sun rises, it sets when the Sun sets. The blue atmosphere of our planet scatters the sunlight, creating a bright curtain that hides everything behind it. The stars are still there during the day, but we cannot see them. And in October 2025, our comet suffered the same fate. The solar exclusion zone, October 25, the first week of October, brought a strange mixture of excitement and disappointment. The mathematical models predicted that the comet was growing brighter by the hour. It was shedding tons of dust and gas. It was developing a tail that likely stretched for millions of kilometers. By all accounts, it should have been spectacular. But for the people on Earth, there was nothing but empty blue sky. The comet had entered what is known as the solar exclusion zone. This is a zone of danger not for the comet but for our instruments. You cannot point a standard telescope at the Sun. If you were to point a sensitive high-powered telescope like the Hubble or the James Webb Space Telescope too close to the Sun, the intense light and heat would fry the sensors instantly. It would be like looking at the midday sun through a magnifying glass. So the observatories shut their doors. The amateur astronomers capped their lenses. The visual tracking that had been updating every hour suddenly stopped. The data feed went silent. This created a profound sense of tension. We knew the object was there. We knew it was currently travelling at staggering speeds, accelerating to hundreds of kilometers per second. We knew it was entering the most violent environment in the solar system, but we were blind. It was like watching a diver jump off a cliff and losing sight of them before they hit the water. You hold your breath waiting to see if they resurface, but the splash is hidden by the rocks. The silence of perihelion. The most terrifying part of this invisibility was the timing. This period of blindness coincided exactly with perihelion. Perihelion is a word derived from Greek meaning near the sun. It is the point in the comet's orbit where it is physically closest to the solar surface. This is the moment of truth. This is the moment of maximum stress. At perihelion, the comet is not just warm, it is being baked. The temperature on the surface of the comet can rise to thousands of degrees. The solar wind, a stream of charged particles blasting out from the sun, hits the comet with the force of a hurricane. The gravity of the sun pulls at the comet's core, trying to rip it apart through tidal forces. For a comet, perihelion is a fight for survival. During those days in October, while Earth saw nothing but the sun shining innocently in the sky, a violent drama was unfolding in the darkness of the glare. The comet was screaming through the solar atmosphere. Was it breaking up? Was the heat causing the core to shatter into a dozen smaller pieces? Was it exploding completely, turning into nothing but a cloud of dust that would never be seen again? Or was it surviving? Was it holding together, forged in the fire, preparing to swing around the sun and emerge as a magnificent spectacle in the morning sky? Down here on Earth, nobody knew. The silence was heavy. Internet forums were filled with speculation. Some said it had already disintegrated. Others hoped it was growing a tail so large it would span half the sky, but without visual proof, it was all just guessing. The solar conjunction had drawn a curtain across the stage right at the climax of the play. The eye is in the void. However, humanity is not limited to the view from the ground. Over the last few decades, we have built sentinels. We have placed robotic eyes in deep space specifically designed to look at the one thing we cannot look at: the sun itself. While the ground-based telescopes were blind, a small fleet of spacecraft was watching. These are the heroes of our story: SOHO Stereo and the GOES satellites. Let us look at SOHO first. The Solar and Heliospheric Observatory is a legend in the space community. Launched decades ago, it sits at a special gravity-neutral point about 1.5 million kilometers from Earth. It has a special instrument called a coronagraph. A coronagraph is a brilliant invention. It essentially creates an artificial solar eclipse inside the camera. It places a small solid metal disc over the center of the lens. This disc blocks out the blinding face of the sun perfectly. With the glare blocked, the camera can see the faint atmosphere around the sun, the corona. And crucially, it can see comets that are sneaking past the sun. In the control rooms, while the rest of the world saw nothing, scientists were glued to the images coming from SOHO. On their screens, the sun was a blocked-out black circle, but sliding into the frame, bright and defiant, was our comet. To the electronic eyes of SOHO, the comet did not look like a fuzzy smudge. It looked like a warrior. In the black and white grainy images, it was saturating the pixels. It was so bright that it created horizontal streaks on the camera sensor. It was alive. Then there was stereo. The stereo spacecraft are different because they are not on the Earth-Sun line. They drift ahead or behind Earth in orbit, looking at the sun from the side. This gave us depth. While Earth was blinded by the glare, stereo had a side view seat. It could see the three-dimensional structure of the tail. It could see how the solar wind was twisting and bending the gas streaming off the comet. And finally, closer to home, we had the GOES 19 satellite. While primarily a weather satellite monitoring Earth, it carries instruments to watch the sun for solar flares. It too joined the watch party. These robots were the only witnesses to the comet's trial by fire. What the robots saw. Through the eyes of these machines, we learned the secrets that the glare was hiding. We saw that the comet was not just surviving, it was reacting violently. As it approached the point of perihelion, the heat caused massive jets of gas to erupt from the surface. These were not gentle streams, they were explosions. The comet was shedding mass at an incredible rate. The images from SOHO revealed something else terrifying and beautiful. The sun, seemingly aware of the intruder, lashed out. A coronal mass ejection. A massive explosion of solar plasma erupted from the sun's surface just as the comet was passing by. From Earth, we saw a sunny Tuesday. From space, we saw a tiny ball of ice navigating through a storm of magnetic fire. The tail of the comet, usually a straight line, was buffeted by this solar storm. In the time-lapse videos sent back by the satellites, we could see the tail detach and reform, a phenomenon known as a disconnection event. The solar wind snapped the tail off like a lizard losing its tail, but the comet immediately began growing a new one, brighter and stronger than before. This was the secret drama of October. While humanity went about its daily business unaware and unable to see a battle of cosmic proportions was taking place just a few light minutes away, The geometry of the solar conjunction had blinded us, but it had not saved the comet from the sun's fury. The object had entered the exclusion zone as a mystery. Now the question remained what would exit the zone. Would the object that emerged from behind the glare be a broken cloud of dust, a ghost of its former self, or would it survive the fire to become the great comet that history had promised? As the days of October ticked by and the angles of geometry began to shift once more, the world prepared to look up again. The moth was leaving the lighthouse. The curtain was about to rise. The silence of deep space was about to be broken not by sound but by energy. For thousands of years, the object known as 3I Atlas had drifted through the frozen void, a sleeping giant wrapped in the absolute zero of the interstellar medium. It was a ghost in the dark, invisible and inert. But as it plunged toward the heart of our solar system, it began to wake up. This was no longer a journey of passive drifting. It was becoming a violent, beautiful transformation. This phase of the journey is what astronomers call the perihelion approach, the moment of closest contact with the sun. It is the ultimate test for any comet. It is a battle between the structural integrity of the object and the overwhelming power of our star. For Atlas, this was not just a physical change. It was a performance on a cosmic stage, a true dance of ice and fire, the Great Awakening, the process of sublimation. To understand what happened to Atlas, we must first understand what it was made of. Like most comets, Atlas was essentially a dirty snowball. It was a chaotic mixture of frozen water, frozen gases like carbon monoxide and carbon dioxide, and ancient dust that had been trapped in the ice since the dawn of time. When a rock approaches the sun, it simply gets hot. But Atlas was not a rock. It was a reservoir of volatile substances that want to turn into gas. As the intensity of the sunlight increased, the surface temperature of the comet began to rise. On Earth, when ice gets hot, it turns into liquid water and then boils into steam. In the vacuum of space, however, liquid water cannot exist. The pressure is too low. So Atlas underwent a violent process known as sublimation. This is the immediate transformation of a solid into a gas, skipping the liquid phase entirely. Imagine a block of dry ice on a steer. It doesn't melt into a puddle, it simply vanishes into a thick fog. This is what began to happen to every square inch of Atlas's sun-facing surface. The ice did not just evaporate quietly, it exploded. Beneath the dark, dusty crust of the comet, pockets of gas expanded rapidly. The pressure built up until it shattered the surface, shooting jets of gas and dust thousands of miles into space. These were not gentle streams. They were geysers of cryovolcanic activity. This gas formed a massive glowing cloud around the nucleus of the comet known as the coma. While the solid heart of the comet was perhaps only a few miles wide, this atmosphere of gas and dust ballooned outward, becoming larger than the planet Jupiter. To an observer, the tiny pinprick of light suddenly became a fuzzy, glowing ball. The dirty snowball was now shedding its skin, releasing dust grains that had been trapped for billions of years. This dust reflected the sunlight, creating a brilliant tail that stretched out behind the comet, pushed away by the pressure of sunlight itself. The mystery of the abnormal brightness. As astronomers watched this transformation, they noticed something strange. Atlas was not just brightening, it was exploding with light. In cometary science, there are standard rules that predict how bright a comet should get as it moves closer to the sun. We usually expect the brightness to follow an inverse square law. Simply put, if you cut the distance to the sun in half, the sunlight hitting the object becomes 4 times as intense. Therefore, the comet should reflect 4 times as much light. However, comets are active, they produce their own atmosphere. So astronomers use a mathematical model called a power law. For a standard comet, the brightness usually increases proportional to the distance raised to the power of -4. This accounts for the sunlight getting stronger and the comet releasing more gas. Atlas, however, decided to break the rules. In the early months of its approach, the brightness of Atlas surged. It was increasing at a rate much higher than the standard power of -4. It was acting as if someone had poured gasoline on a fire. This rapid brightening suggested that Atlas was hyperactive. Why was this happening? The scientific consensus pointed to the surface composition. It is likely that Atlas was covered in extremely volatile ices, specifically carbon monoxide and nitrogen ices, which sublimate at very low temperatures far lower than water ice. Because Atlas was a fresh visitor, or at least one that hadn't been to the inner solar system in a very long time, its supply of these volatile ices was untouched. It still had its baby fat. As soon as the sun's heat touched it, these super-sensitive ices reacted explosively, throwing out much more material than a typical older comet would. The surface was shedding layers at a catastrophic rate, exposing fresh bright ice underneath which then immediately sublimated, creating a runaway feedback loop of brightness. The tension of matters. A structure under siege. While the brightening was a spectacle for the telescopes, it was a warning sign for the physicists. A comet that brightens that fast is a comet that is dying. We often think of astronomical objects as solid, indestructible things like moons or asteroids, but comets are incredibly fragile. They are often described by geologists as rubble piles. Imagine a collection of rocks, gravel and sand held together not by strong cement, but by weak gravity and frozen glue. They are mostly empty space, porous and light. If you could place a comet in a giant ocean, it would likely float. As Atlas raced towards the Sun, it faced two invisible enemies: thermal stress and tidal forces. Thermal stress is caused by the rapid change in temperature. The side of the comet facing the Sun was roasting, while the dark side remained in the freezing cold of deep space. This extreme difference creates massive tension within the rock and ice. The materials expand and contract, causing deep fractures to run through the core of the nucleus. It is similar to pouring boiling water into a cold glass. The glass shatters. Simultaneously, the comet was fighting tidal forces. As it got closer to the Sun's massive gravity began to pull on the front of the comet harder than it pulled on the back. This stretching force tried to pull the comet apart. For a solid rock, these forces are manageable, but for a rubble pile like Atlas, which was already spinning and violently outgassing, this was a recipe for disaster. The centrifugal force from its rotation, combined with the pressure of the escaping gas jets, acted like a centrifuge trying to fling the pieces of the comet outward. The rapid brightening was actually a symptom of structural failure. The reason it was getting so bright so fast was likely because the nucleus was cracking open, increasing the surface area and allowing even more ice to vaporize. It was burning the candle at both ends. The dance was becoming a death spiral, dispelling the rumors nature, not engineering. Whenever an object from deep space behaves strangely, the human imagination turns to the fantastic, just as with the interstellar object Oumuamua. A few years prior, the internet began to whisper. Was this an alien spacecraft? Was the rapid brightening an engine firing up? Was the trajectory artificial? Science, however, requires us to look for the simplest explanation that fits the facts. In the case of Atlas, the alien hypothesis falls apart when we look at the data, while the natural hypothesis fits perfectly. First, there is the tail. Alien spacecraft, at least in theory, would not drag a massive cloud of dust and gas millions of miles long behind them. That is a signature of a natural dirty body disintegrating. Atlas had a very prominent, very classic cometary tail. Second, we must look at the movement. It is true that comets often deviate slightly from a purely gravitational path. This is called non-gravitational acceleration. Conspiracy theorists often point to this as proof of engines. However, the physics of sublimation explains this perfectly. When a jet of gas shoots out of a comet, it acts exactly like a rocket thruster. For every action, there is an equal and opposite reaction. If a massive geyser of carbon monoxide shoots out toward the Sun, the comet is pushed slightly away. Because Atlas was outgassing so violently, these rocket effects were significant. It was not being steered by a pilot, it was being pushed around by its own evaporating gases. Furthermore, the spectral analysis, the study of the light reflected by the comet, revealed the fingerprints of standard chemicals: carbon, hydrogen, oxygen, and nitrogen. There were no signatures of refined metals or artificial alloys. The reality of Atlas is actually more profound than a spaceship. A spaceship is built. It is static. Atlas was a remnant of the chaotic swirl that created our solar system 4.5 billion years ago. It was a time capsule preserved in the deep freeze, now being cracked open by the sun to reveal the chemical recipe of our origins, the final act of the dance. As part 3 of this saga concludes, we leave Atlas in a precarious position. It is shining brighter than many stars, a fuzzy emerald in the night sky. It is spinning, hissing, and cracking. The sun is stripping it bare, demanding a sacrifice of mass in exchange for the brilliance it displays. The world watched with bated breath. Would it survive the perihelion? Would it swing around the sun and return to the deep dark, or had the heat already dealt a fatal blow? The rapid brightening, the beautiful coma, and the erratic behavior were all clues. The dance of ice and fire was reaching its crescendo, and the ice was losing. The structure was groaning under the weight of its own activity. The very thing making it beautiful, its volatility, was the very thing that was doomed to destroy it. To truly understand the magnitude of 3i Atlas, we must first look backward. We must place this new visitor on the timeline of our cosmic awakening. For centuries, astronomers looked up at the night sky and assumed that our solar system was a relatively closed room. We knew that comets lived in the distant freezer known as the Oort cloud, and occasionally one would fall inward toward the sun. But we assumed that everything we saw belonged to us born from the same cloud of gas and dust that created the Earth 4.5 billion years ago. We believed the space between stars was vast and empty. We thought that if objects did drift across the void from other stars, they were so rare or so dark that we would never see them. That illusion shattered in October 27, the Fizz messenger, the mystery of Oumuamua. It began with a streak of light caught by a telescope in Hawaii. At first, the computers thought it was a normal rock, perhaps a near-Earth asteroid, but the math did not add up. This object was moving too fast. It was not orbiting the sun, it was piercing through our system like a bullet. We named it Wani Oumuamua. The I stood for interstellar. The number 1 marked it as the very first. The name itself is Hawaiian, meaning a messenger from afar arriving first. Oumuamua was a shock to the system. It did not look like the comets we were used to. It had no tail, no fuzzy cloud of gas surrounding it, and it did not shine brightly. As telescopes tracked it, they realized its light was flickering rhythmically. This told us it was tumbling end over end, a chaotic motion that had likely been happening for millions of years. Based on how the light changed, astronomers calculated its shape. It was not a round sphere. It was elongated, stretched out like a cigar or a flat pancake, perhaps 10 times longer than it was wide. We had never seen a space rock with such extreme proportions, but the true mystery was its movement. As Oumuamua left the solar system, it accelerated. It moved faster than gravity alone could explain. Usually when a comet speeds up, it's because ice is melting and shooting out jets of gas acting like a rocket thruster. But Oumuamua showed no signs of gas, no tail, and no dust. It was a silent ghost. This anomaly led to wild theories. Was it a hydrogen iceberg that was invisible to our cameras? Was it a dust bunny made of loose fluff pushed by sunlight, or as some dared to whisper, was it artificial, a piece of ancient alien technology drifting through the stars? Oumuamua left us with more questions than answers. It was the strange traveller, the second traveller. The familiarity of Borisov. 2 years later in 2019, the second guest arrived. This time it was discovered not by a massive observatory, but by an amateur astronomer named Gennady Borisov. We named it 2i Borisov. If Oumuamua was the mysterious stranger standing in the shadows, Borisov was the friendly neighbour knocking at the door. When we pointed our telescopes at 2i Borisov, we breathed a sigh of relief. It looked exactly like a comet should. It had a bright tail. It had a fuzzy coma, the atmosphere around the nucleus. As it got closer to the sun, it began to heat up. Our instruments analysed the light coming from it and found water vapour. We found carbon monoxide. We found cyanide. These are the exact same ingredients found in the comets of our own solar system. This was a profound discovery in its own right. It told us that the chemistry of the galaxy is universal. It proved that other stars have Oort clouds just like ours, filled with icy bodies that are chemically similar to the ones in our own backyard. 2i Borisov was the normal traveller. It confirmed that the process of planet formation happens everywhere, scattering the same building blocks across the universe. The portrait of 3i Atlas. And now we stand before the third traveller, 3i Atlas. 3i Atlas represents the synthesis of its two predecessors. It bridges the gap between the baffling strangeness of Oumuamua and the comforting familiarity of Borisov. When 3i Atlas first appeared on our sensors, it showed the high-speed characteristic of an interstellar object. It dropped into our system from an angle that is impossible for local planets or asteroids, piercing the plane of the solar system almost perpendicularly. Visually, 3i Atlas is a study in contradictions. Unlike the dark rocky surface of Oumuamua, Atlas E has a surface that reflects light with a peculiar intensity. It is not quite the dirty snowball of a typical comet, but it is not a metallic slab either. It appears to be covered in a frost that has survived a journey of light years, a crust of exotic ices that we rarely see in such concentrations. As it approaches the heat of the sun, 3i Atlas begins to wake up, but not in the way Borisov did. Borisov vented gas in all directions, creating a messy cloud. Atlas is different. It releases distinct sharp jets of material. These jets are powerful and focused, causing the object to alter its rotation. It is as if the object is alive, reacting violently to the warmth of our star after spending eons in the absolute zero of deep space. The composition of 3i Atlas is the true marvel. While Borisov brought us water and carbon preliminary readings suggest Atlas is carrying heavier, more complex organic molecules, it is carrying the stuff of life packaged in a shell that is harder and denser than any local comet. This is why it is the hybrid traveller. It has the non-gravitational movement that puzzled us with Oumuamua, yet it displays the outgassing tail that comforted us with Borisov. It suggests that there is a class of objects between rock and ice, a transition point in planetary formation that we have never been able to study close up until now, the significance of 3I. The name 3I sounds technical as simple catalogue number, but in the history of astronomy it is a badge of honour. It stands for rarity. Consider the millions of asteroids we have catalogued. Consider the thousands of comets we have tracked. In all of history we have lists that go on for pages and pages. 1P Halley, 67P Asteroid Vesta Asteroid Series. But in the column marked Interstellar, there are only 3 entries. 1I, 2I, 3I. The label I confirms that this object was not born here. It was not formed from the dust of our sun. It was cooked in the kiln of a different star, perhaps a star that died long ago, or a star that is currently shining on the other side of the Milky Way. The 3I designation is a passport stamp from an alien nation. However, this number also reveals our own limitations. The fact that we are only at number 3 is not because these objects are rare in the galaxy, it is because we have been blind. A galaxy full of ghosts. This brings us to the most humbling realization that 3I Atlas offers us. Astronomers estimate that at any given moment there is at least one interstellar object of this size inside the orbit of the Earth. If you zoom out to the orbit of Neptune, there are likely 10,000 of them passing through right now. If we look at the galaxy as a whole, the numbers become impossible to comprehend. There are likely trillions upon trillions of these wanderers drifting through the Milky Way. They are the shrapnel of planetary formation. Every time a solar system forms, giant planets like Jupiter throw smaller rocks out into the dark. These rejected stones float forever untethered to any star drifting in the cold silence for billions of years. For most of human history, they passed through our solar system unseen. They were too small, too dark, and too fast for our ancestors to notice. We were like people living in a house with the windows boarded up, thinking we were alone while thousands of birds flew past outside. Technology has finally pulled the boards off the windows. Oumuamua was the first bird we saw, Borisov was the second, 3I Atlas is the third, but 3I Atlas is special because we are ready for it. With Oumuamua, we were caught by surprise. We only saw it as it was leaving. With Borisov, we were just learning how to look. With Atlas, we have the experience of the first 2. We are tracking it earlier. We are listening closer. Atlas is not just a rock, it is a statistic coming to life. It proves that the space between stars is not empty. It is a busy highway filled with the debris of creation. Each of these objects is a time capsule, a frozen fragment of a distant world. As 3I Atlas swings past our sun, we are not just looking at a comet. We are looking at a piece of a puzzle that was cut from a different box. We are realizing that while our solar system is our home, the galaxy is a community, and its residents are finally coming to visit. We have moved from the shock of the first to the understanding of the second, to the deep study of the third. 3I Atlas is the beginning of a new era where interstellar astronomy moves from theory to reality. We are no longer just observing our own history, we are beginning to read the history of the galaxy one traveller at a time. To hold this object in your mind is to hold a piece of eternity. When we look at the history of our own home, the Earth, we are looking at a story that is about 4.5 billion years old. That number is so large it is hard to understand, but the visitor that passed through, our sky, the dark red messenger from the stars, makes our Earth look young. The data tells us a story that is almost impossible to believe. This object is likely 7 billion years old. It is older than the ground you stand on. It is older than the water in our oceans. It is older than the sun that warms your face. In fact, this traveller was already wandering the dark spaces of the universe long before our solar system even began to form. To understand its age, we must travel back in imagination. We have to go back before there was a blue planet or a yellow sun. We have to go back to a time when our corner of the universe was just empty darkness and quiet dust. Imagine a place far away in a different part of the galaxy. This is the birthplace of our visitor. It was likely born in a giant cloud of gas and dust called a nebula. These places are often called stellar nurseries because they are where stars are born. Picture a chaotic, beautiful scene. There were no solid planets yet, just swirling clouds of purple, pink and blue gas, hotter than anything we can create on Earth. In this violent and energetic place, stars were popping into existence. Gravity was pulling dust together, squeezing it until it ignited into nuclear fire. Around these new stars, rocks and ice began to crash into each other. They were building planets. It was a messy, dangerous construction zone. Our object was born here. It was forged in this ancient fire. It was likely a piece of a planet that never finished growing, or perhaps a piece of a larger world that was smashed apart by a collision. It was created from materials that had been cooked inside even older stars that had died long before. It carries within its frozen body the chemical history of a part of the galaxy we will never see, but it did not stay there. In the chaos of that young star system, gravity was a bully. Giant planets, perhaps similar to our Jupiter, were swinging around, pushing and pulling at everything nearby. One day, about 7 billion years ago, our object wandered too close to one of these giants. It received a massive kick from the giant planet's gravity. It was thrown outward like a stone skipped across a pond, but with much more power. It was flung so hard that it escaped the gravity of its own sun. It left its home, it crossed the boundary of its solar system and entered the cold, empty void between the stars. This is where the true journey began. For the next 7 billion years, it did absolutely nothing but travel. Try to imagine the seance. For us, a long trip is a few hours on a plane. A long time is a few decades of life. For this object, time means something completely different. It drifted through the interstellar darkness while the universe changed around it. While it was floating in the dark, our sun finally ignited. While it was drifting, the Earth formed from dust. While it was moving silently through the void, life began in the Earth's oceans. While it continued its lonely path, dinosaurs rose up, conquered the Earth, and then went extinct. While it approached our neighborhood, humans learned to walk, discovered fire-built cities, and invented telescopes. All of human history, every war, every love story, every invention happened in the blink of an eye compared to the time this stone has been traveling. It has been frozen in a deep sleep preserved perfectly by the cold of space, holding its memories of 7 billion years ago. Then it arrived. This brings us to the shape of its journey, something scientists call a hyperbolic orbit. This is a mathematical way of describing a path that never closes. Most things we know in space move in circles or ellipses, which are stretched out circles. The Earth moves in an almost circle around the Sun. We go around and around. Every year we return to roughly the same spot. This is a closed loop. It implies belonging. We belong to the Sun. Even comets that take hundreds of years to return eventually come back. They are on long, stretched-out elastic bands that pull them back home, but a hyperbolic orbit is different. It is an open curve. It looks like a check mark or a wide U-shape. In the language of gravity, a hyperbola means escape. It means the object is moving too fast to be caught. When this object entered our solar system, it wasn't falling into the Sun. It was diving past it. It was moving at a speed that screamed, "I am not from here." It was traveling at nearly 200,000 miles per hour. The Sun tried to grab it with gravity to pull it into a relationship to make it orbit. But the object was too fast. The Sun only managed to bend its path slightly, just enough to slingshot it back out toward the stars. This implies a profound reality. This was a one-way trip. It will never come back. Oh, we will never see it again. It came from the unknown, briefly passed through the light of our campfire, and has now returned to the dark forest. It is heading toward the constellation of Pegasus, but it won't stop there. It will continue to drift for another 7 billion years, and another likely outliving our Sun and our Earth. Finally, we must look at this rock and then look at ourselves. The existence of this 7 billion-year-old wanderer forces us to feel a sense of deep humility. We often think our lives are long. We think our daily problems, our traffic jams, our arguments, our deadlines are the most important things in the universe. We stress over minutes and hours. But to this object, our entire existence is less than a heartbeat. If the life of this object were compressed into a single 24-hour day, all of recorded human history from the ancient pyramids of Egypt to the smartphone in your pocket would take up less than the last fraction of a second before midnight. It reminds us that we are newcomers to the universe. We are the babies of the galaxy. This rock was old before our solar system was born. It has seen the galaxy turn and shift. It is a silent witness to the deep history of the cosmos. There is a beauty in this insignificance. It allows us to step back and breathe. It tells us that the universe is vast, ancient, and full of mysteries that do not care about our schedules. This visitor was a messenger from the deep past knocking on our door for a brief moment before leaving forever. It did not stay to answer our questions. It did not slow down for our cameras. It simply showed us that the universe is bigger, older, and stranger than we usually dare to imagine. It leaves us with a feeling of mono-no aware, a Japanese phrase for the gentle sadness of things passing. We are sad to see it go, but we are lucky to have seen it at all. The memory of 7 billion years passed within a few million miles of Earth, and now it carries the memory of us back out into the eternal dark. When we look up at the night sky, we usually appreciate the stars for their beauty or their position. We connect the dots to form constellations, or we marvel at the sheer number of points of light. However, to a scientist, light is much more than just a picture. Light is data. It is a physical carrier of information, a courier delivering a message across the vast ocean of space. When an object like Oumuamua streaks past our planet, or when we gaze at distant comets and nebulae, we are not just looking at their shape, we are trying to taste them, we are trying to smell them. And surprisingly, we can do this without ever leaving the ground thanks to the hidden language written inside every beam of light. To understand what Oumuamua and other interstellar travelers are made of, we have to rely on a technique that feels almost like magic. It is called spectroscopy. To put it in the simplest terms, spectroscopy is the art of reading the rainbow. We all know that if you pass sunlight through a glass prism, it splits into a beautiful band of colours: red, orange, yellow, green, blue, indigo and violet. This happens because white light is actually a mixture of all these colours. But here is the secret that astronomers realise: that rainbow is not perfect. If you look at it very closely through high-precision instruments, you will see missing pieces. There are thin dark lines slicing through the colours like a barcode you might see on a product in a supermarket. These dark lines are the fingerprints of the cosmos. Every chemical element in the universe interacts with light in a unique way. For example, carbon loves to eat specific shades of light. Oxygen prefers others. Hydrogen has its own favourite colours to absorb. When light reflects off an object like Oumuamua, or passes through the gas of a comet, the atoms on that object steal specific colours from the light. By the time that light reaches our telescopes, those colours are missing. By looking at which colours are missing by reading the barcode, we can tell exactly what the object is made of. We can say with absolute certainty that a rock moving millions of miles away contains frozen water or carbon or iron just by looking at the gaps in its light. This is where the titans of modern astronomy, the Hubble Space Telescope and the newer, more powerful James Webb Space Telescope, come into play. They are the supreme readers of these cosmic barcodes. While Hubble has spent decades looking at the visible light that our eyes can see, the James Webb Telescope looks at the universe in infrared, a type of light that is invisible to us but is perfect for hunting down heat and chemicals in deep space. Through the eyes of these telescopes, we have begun to identify the specific recipe of the universe. When they look at interstellar objects, comets, and star-forming regions, they are hunting for three very specific, very important ingredients: water, carbon, and hydroxyl. Let's start with water. In the language of chemistry, we usually write this with symbols, but here we simply call it the combination of 2 hydrogen atoms and 1 oxygen atom. Finding water in space is always a profound moment. For a long time, humanity thought of water as something special to Earth, the blue marble. But the fingerprints in the light tell us a different story. Water is everywhere. It is one of the most common compounds in the universe. When telescopes catch the signature of water ice on a distant body, it tells us that the environment there is not so different from the frozen reaches of our own solar system. It implies that the basic fluid required for life as we know it is waiting in the dark, frozen in vast quantities, ready to melt if it ever gets close enough to a warm star. Then there is carbon. Carbon is the backbone of biology. Yumi, the trees outside, and the food we eat are all based on carbon. In the vast emptiness of space, telescopes look for carbon-based molecules. These can range from simple gases like carbon dioxide to complex chains that look like soot or smoke. When we detect carbon on an object like Oumuamua, or in the dust clouds of other solar systems, it confirms that the building blocks for life are not unique to Earth. The universe is rich with the raw materials needed to build living things. It is as if the cosmos is a giant kitchen stocked with all the right flour and sugar waiting for the right baker, a planet to mix them together. The third key signature is hydroxyl. This is a molecule made of just 1 oxygen atom and 1 hydrogen atom. It acts like a chemical cousin to water. Hydroxyl is often what scientists look for when water is being broken apart by sunlight. It is a signpost. If you find hydroxyl, you usually find water. It helps astronomers understand how the harsh radiation of the stars interacts with the icy surface of a comet or an asteroid. It tells us about the history of the object, how long it has been baking in the sun, and what layers of its surface are being peeled away. The detection of these three things, water, carbon, and hydroxyl, on objects from deep space leads us to a realization that is both scientific and deeply emotional: the universe is uniform. This is the cosmic consistency. Before we had this technology, we could have imagined that other star systems were made of exotic, impossible materials matter that followed different rules, but the light tells us that a hydrogen atom in the Orion Nebula is identical to a hydrogen atom in a cup of tea in London. The ice frozen on the surface of an interstellar visitor is the same kind of ice that sits in your freezer. The laws of physics and chemistry do not change when you cross the border between solar systems. This uniformity is what allowed us to understand Oumuamua, even though it was so mysterious. When we analysed the light reflecting off its surface, we saw a reddish hue. In our own solar system, a red surface on an icy object usually means the presence of organic materials, complex carbon mixtures that have been bombarded by cosmic radiation for millions of years. This radiation acts like a slow oven, baking the carbon on the surface into a thick red crust. This crust protects the ice hidden underneath. By reading this colour, scientists could infer that Oumuamua was wrapped in a layer of organic insulation protecting its frozen heart from the heat of our sun. This brings us to the most magical part of this scientific process: the emotional connection to the material itself. Think about what it means to see the signature of water on an object that came from another star. That water was not created here. It was not part of the cloud of gas that formed our sun and our Earth. That water was formed in the crushing darkness of a nebula billions of miles away. It froze around a grain of dust in the orbit of an alien star. It may have been part of a comet that circled a planet we will never see, and then through some gravitational kick it was thrown out into the cold void between the stars. It travelled for ages. It drifted through silence and darkness for longer than humans have walked the Earth. And then for a brief moment it dipped into our solar system, the sunlight hit it, and that light bounced back into our telescopes. When we analyse that light and say, "This is water," we are acknowledging a physical traveller from the great beyond. It changes how we view our place in the galaxy. We often feel isolated on Earth, separated from the rest of the universe by impossible distances, but the chemistry proves we are connected. We are made of the same stuff. The carbon in our bodies and the carbon on a wandering interstellar rock are kin. We are not apart from the universe, we are a part of it. This is why the work of telescopes like James Webb is so vital. They are not just taking pretty pictures for wallpapers, they are performing an autopsy on the light itself to tell us the biography of the cosmos. They are hunting for the fingerprints that prove we are not alone in a chemical sense. Every time they identify water or carbon on a distant world or a passing visitor, they reinforce the idea that the conditions for life, or at least the ingredients for it, are common. The universe is wet, it is carbon-rich, and it is filled with the potential for chemistry to become biology. So when we think about the fingerprints of the cosmos, we are thinking about a universal language. A language spoken not in words but in wavelengths of light. It is a language that tells us that no matter how strange or alien an object like Oumuamua may seem with its odd cigar shape and its tumbling motion, it is still built from the same fundamental bricks as we are. It validates the feeling of wonder we get when we look up. We are looking at a family history written in the stars, decoded by the prism and understood by the human mind. We are touching the stars one wavelength at a time. We have arrived at the last chapter of this celestial journey. After weeks of excitement, headlines, and brilliant displays, we are now entering the phase known as the final window. This is not the time for casual glancing, it is the time for serious, intentional observation. The comet is no longer a bright beacon shouting for attention. It is becoming a whisper, a ghost sliding into the deep darkness of space. For the dedicated observer, this is the most rewarding time because it requires skill, patience, and a true love for the night sky. What follows is a guide designed for you to imagine yourself standing in the dark, looking up and finding this traveller one last time before it vanishes for thousands of years, navigating the starry path. To find our fading guest, you must know where to look. The comet is moving along a specific track against the background of the stars. It is not staying in one place. Over the coming weeks, it will travel through 3 major constellations. Think of these constellations as the signposts on a highway. The Archer, Sagittarius. The journey begins in the realm of Sagittarius. In simple terms, this group of stars looks very much like a teapot. If you look low towards the horizon, you can imagine a spout, a lid, and a handle made of stars. This is a rich part of the sky because when you look towards Sagittarius, you are looking toward the centre of our own Milky Way galaxy. For the first few nights of this period, the comet lingers here. It will be low, sitting heavily in the sky. Because Sagittarius is often associated with the summer sky, seeing the comet here in the colder months feels strange and special. The comet will appear to be moving away from the spout of the teapot, as if it is steam being poured out into the universe. The maiden Virgo. As time passes, the comet moves higher and shifts eastward into the constellation of Virgo. This is a very large group of stars. The easiest way to know you are looking in the right direction is to find the bright star Spica. Spica is a blue-white sparkles that anchors this part of the sky. When the comet crosses into Virgo, it is entering a lonely, dark part of the sky. There are fewer bright stars here to distract you, which is good. However, the comet is also getting dimmer. It will look like a small, fuzzy patch of light floating near the imaginary shoulder of the maiden. This is the middle of our viewing window. The Lion, Leo. Finally, toward the very end of this period, the comet will drift toward the constellation of Leo. The lion is distinct and easy to find because its head looks like a backward question mark and its body is a triangle. By the time the comet reaches the paws of the lion, it will be very faint. Only those with sharp eyes or good equipment will be able to spot it. It will be a tiny smudge against the chest of the lion, waving goodbye as it heads into the vast emptiness beyond. The golden hour watching before the sun wakes. Timing is everything. During the peak of the comet's brightness, we might have looked for it in the evening. But now the geometry of the solar system has changed. The window of opportunity has shifted to the early morning. The golden hour for this final viewing is strictly before sunrise. You must wake up early. You need to be outside and ready about 90 minutes to 2 hours before the sun comes up. This is the coldest, quietest part of the night. The world is asleep. The air is usually still, which helps with seeing details in the sky. Why this specific time? It is because of the angle of the sun. We need the sky to be as dark as possible. If you wait too long, the sun will start to brighten the eastern horizon. This glow, which we call twilight, is the enemy of the comet watcher. The comet is now faint. Even a little bit of blue light from the coming day will wash it out and make it invisible. Imagine standing there in the cold. The sky is black. The stars are sharp. You are racing against the clock. You have perhaps 45 minutes of perfect darkness before the sky begins to turn purple, then blue, and the view is lost. This urgency adds to the excitement. You are stealing a view of the universe while the rest of the world sleeps. The challenge of the fading ghost. I must be honest with you, this will not be easy. In the earlier days, the comet was a showstopper. Now it is a challenge. This is a test of your patience and your eyes. The fading light. Every day, the comet moves further away from the sun. The sun is what powers the comet, heating it up and making it glow. As it moves away, it cools down. The tail, which was once long and bright, becomes shorter and thinner. The bright center or the nucleus becomes less intense. You are looking for something that is not a sharp point of light like a star. You are looking for a fuzz. It will look like a small cotton ball or a smudge of chalk on a blackboard. Fighting the light. To see this, you cannot be in the city. Streetlights, car headlights, and even the light from your neighbor's porch will ruin the view. You need true darkness. If you can, you must travel to a place where the city lights are far away. Even the moon can be a problem. If the moon is full and bright, it acts like a giant natural street light. The best nights to watch are when the moon is a thin crescent or when it is already set below the horizon. Using your eyes correctly. There is a trick that astronomers use called averted vision. This sounds technical, but it is simple. The center of your eye is good at seeing color, but it is not good at seeing faint light in the dark. The side of your eye is much more sensitive to dim light. When you think you have found the spot where the comet is, do not look directly at it. Look slightly to the side of it. Look a little bit to the left or the right. Suddenly you might see a pop of light in the corner of your vision. That is the comet. If you look straight at it again, it might disappear. You have to play hide and seek with your own eyes. The Virtual Telescope Project bridging the distance. Not everyone can travel to the countryside. Not everyone can wake up at 4 in the morning. And sometimes the weather simply does not cooperate. Clouds are the curtain that ends the show. However, we live in an age of miracles. This is where the Virtual Telescope Project becomes the hero of our story. Imagine a set of powerful robotic telescopes located in perfect locations, perhaps on top of a mountain in Italy or in a desert in Chile. These telescopes are controlled by computers. They do not sleep and they do not get cold. The Virtual Telescope Project connects these robotic eyes to the internet. You can sit in your living room with a warm cup of coffee and watch a live stream on your computer screen. How it works. The project uses cameras that are much more sensitive than the human eye. These cameras can leave their shutters open for many seconds or even minutes. This allows them to gather light that our eyes would miss. When you watch through the virtual telescope, you see more than just a smudge. You might see the green color of the gas around the comet. You might see the faint structure of the tail. The camera reveals the hidden beauty that distance has tried to steal from us. It also creates a community. When you watch online, you are watching with thousands of other people from around the world. You're all sharing the same digital window, looking at the same ancient rock, sharing the same moment of wonder. It is technology bridging the gap between the human desire to explore and the physical limitations of our bodies and locations. December 19th, the closest approach and the goodbye. Mark the date, December 19th. This date is scientifically significant, but it is also emotionally powerful. On this day, the comet reaches a point called the perigee. This means it is at its closest physical distance to Earth during this part of its orbit. You might think, if it is closest to us, shouldn't it be the brightest? Nature is tricky. While the comet is physically close to Earth millions of kilometers away, but close in space terms, it is also very far from the Sun. The Sun is the spotlight, and the comet is walking off the stage away from the light. So even though it is near us, it is not illuminated enough to be brilliant. It is like a friend walking past your house in the dark. They are close, but you can barely see them because there is no street lamp. The farewell. December 19th marks the beginning of the true goodbye. After this date, the geometry changes again. The comet will continue to move away from both the Earth and the Sun. It will retreat into the freezing cold outer reaches of the solar system. Every night after the 19th, it will get significantly harder to see. The distance grows by millions of kilometers every day. The gravity of the Sun is slowing it down, but it is still moving incredibly fast, rushing back to the Oort cloud, the mysterious icy shell that surrounds our solar system. A moment of reflection. When you look up on this night or watch the screen of the virtual telescope, take a moment to think about what you are seeing. You are looking at a time capsule. This object was formed at the very birth of our solar system 4.5 billion years ago. It carries the original ice and dust that created the planets. It has visited us, warmed up, released its dust, and is now returning to the freezer. It will not return in our lifetime. It will not return in the lifetime of our children or our children's children. Depending on its exact speed, it might not return for tens of thousands of years, or perhaps never again. This final window is your last chance to be a witness. It is an invitation to stand in the dark, to feel small beneath the vast canopy of stars, and to say farewell to a traveller that has journeyed billions of kilometres just to grace our skies for a few fleeting weeks. Do not let the cold or the early hour stop you. The universe is putting on a show and the curtain is about to fall. By January of 2026, the silence will officially begin. For the last few years we have watched, measured and listened, but the universe is vast and our reach has limits. There comes a specific moment when the object known as 3i Atlas slips beyond the final range of our most powerful telescopes. It does not announce this departure with a bang or a flash of light. Instead, it simply fades. It becomes too small, too dark and too distant for even the sharpest lenses to resolve against the black velvet of deep space. The signal, which was once a loud shout of data, turns into a whisper, and then finally into nothing at all. At this moment, the object ceases to be a scientific subject and transforms into a memory. It is no longer something we can study. It is something we can only remember. It moves past the invisible boundary where our instruments can follow, crossing into the true unknown. It is leaving the warmth of our sun behind forever. The temperature on its surface drops steadily, returning to the absolute chill of the void hundreds of degrees below zero. Any gas that was venting, creating that beautiful tail we saw, freezes instantly back into solid ice. The traveller is going back to sleep. As it drifts further away, the sun becomes just another bright star in the sky, no larger or more significant than any other point of light. To Atlas, Earth is now invisible, lost in the glare of the star we call home. The noise of our planet, our radio waves, our television signals, our digital chatter, eventually fades into the background radiation of the galaxy. The object is now truly alone. Imagine the future of this lonely traveller. This is not a journey of years or decades, but of eons. It will drift through the interstellar darkness for millions of years. It is entering a state of preservation that we can barely comprehend. Here on Earth, wind and rain erode mountains, steel rusts, civilizations rise and fall. But out there in the vacuum between the stars, nothing changes. Without air to cause friction or heat to cause melting, the object will remain exactly as it is today. It is a perfect time capsule, a frozen monument to the time it visited us, sailing silently through the dark. It will pass other stars, but the distances are so great that it may never get close to another solar system again. It will float through the empty canyons of the Milky Way, tumbling slowly end over end in total silence. There is no sound in space to mark its passing. There is only the slow, rhythmic rotation of the ice and rock dancing a solitary waltz that will last for billions of years. It is a ghost ship carrying no crew steering, no course, simply surrendering to the gravity of the galaxy. Thinking about this eternal journey brings us to a profound realization about our own lives. It is easy to feel small when looking at the night sky, to feel insignificant against the scale of such a long voyage. But there is another way to look at it. Think of the sheer mathematical improbability of the last few years. This object travelled for millions of years before it reached us. It crossed unimaginable distances, dodging stars and nebulae, to arrive in our solar system at the exact moment that humanity existed and had the technology to see it. If it had arrived 500 years ago, we would have thought it was a demon or a god, or perhaps we would not have seen it at all. If it had arrived 500 years from now, we might have been too advanced to care, or perhaps gone altogether. But it came now. Out of all the time in the history of the universe, our timelines intersected for this brief, sparkling moment. We are the witnesses. We are the only eyes in the universe that saw it wake up, stretch its wings, and fly past. We gave it a name. We gave it a story. Without us, it would have just been another silent rock in the dark. Because of us, it became a legend. This is the lesson the traveller leaves behind as it vanishes into the void. It reminds us that being alive right now at this specific second in the history of the cosmos is a rare and beautiful gift. We are the universe experiencing itself. We are the watchers on the wall. The fact that we could look up, point a telescope at a tiny dot of light and understand what it was is a triumph. It connects us to the deep past and the far future. We touched eternity for a moment, and though it has slipped through our fingers, the memory remains ours to keep. Now the show is over. The curtains of the cosmos are closing on this particular act. The excitement of the discovery settles down into a calm acceptance. The data has been collected, the papers have been written, and the arguments have cooled. What is left is peace. The sky above you is vast and deep, and somewhere out there in a direction you can point to but cannot see our frozen visitor is continuing its endless float. Let your mind drift with it now. Imagine you are matching its speed, floating alongside it. There is no gravity pulling you down. There is no weight on your shoulders. There is only the gentle, weightless sensation of drifting. The darkness around you is not scary. It is soft and comforting, like a heavy blanket pulled up to your chin. The silence is not empty. It is restful. It is the sound of total tranquility. Visualize the object turning slowly over and over. It catches a glint of starlight on a ridge of ice, shining for a second before turning back into the shadow. It is calm. It is in no rush. It has nowhere to be and an eternity to get there. Let yourself mimic that slowness. Let your breathing slow down to match the rhythm of that distant tumbling stone. In and out, slow and steady. Everything is exactly where it is supposed to be. The stars are in their places, the planets are moving in their tracks, and you are safe in your bed, grounded on this beautiful blue planet that gave us the chance to look up and wonder. The story of the traveller has ended, but your rest is just beginning. Release the thoughts of the day just as the sun released the comet. Let them drift away from you, getting smaller and smaller until they disappear into the distance. You don't need them anymore. You are entering your own personal void, a space of dreams and quiet. It is time to let go. It is time to float. Good night to the traveller in the dark. Good night to the stars watching overhead. And good night to you. Sleep well and drift peacefully into your dreams.